Dear students, welcome to lecture 14. Today we are going to talk about heterocyclic aromatic compounds, and the next compound that we are going to study is indole. So, what is indole? Indole is a heterocyclic compound which has a six-membered ring fused with a pyrrole ring. A six-membered benzene ring is fused to a five-membered pyrrole ring. Whenever these such fused structures are present, we call it indole. So indole is a very important organic compound, and it is present in many biologically important molecules like tryptophan and neurotransmitter serotonin, also known as 5-hydroxytryptamine. So tryptophan and serotonin, both of them contain a indole ring. Tryptophan in fact is an amino acid which is a basic component of many proteins and has very important roles because of its indole ring. This indole compound is a solid at room temperature and it boils at 253 degrees Celsius. So let us turn towards the synthesis of indole. Indole can be synthesized from phenylhydrazine using the Fischer-Indole synthesis. We have discussed this in last lecture. Another way to synthesize indole and its derivatives is from the acyl amidotoluene derivatives. When these are acyl amidotoluene are treated with strong bases like potassium tertiary butoxide or sodium amide, the cyclization takes place to give indole or indole derivatives depending on what is the R. If it is a methyl group, we will get to methyl 1H indole. If it is a hydrogen, we will get indole. So the mechanism of this reaction can be understood like this, that because of the acidic character of this benzyl proton, potassium tertiary butoxide acts like a base and abstracts this proton to form a carbon anion here. This carbon anion then attacks on the adjacent carbonyl group to form the cyclic structure alcohol, which loses a molecule of water and forms a double bond at this place to give us the substituted indole derivative. Two substituted indole derivative. Similarly, use of this acidic character of the toluene protons is made in a rest in which nitrotoluene is reacted with diethyl oxalate, and therefore the carbon anion first generated here attacks on the oxyl carbonyl atom to form this intermediate compound. This compound is then reduced at the nitro group using zinc acetic acid, gets converted into amino group. Because of the nucleophilicity of the amino group, it attacks on the adjacent carbonyl carbon to form a cyclic indole like structure. This then loses a molecule of water to the solvent and forms the ethyl 1H indole 2 carboxylate. Ethyl 1H indole 2 carboxylate. Now let us turn towards the reactions of indole. Indoles undergo reactions like Mannich reaction because of the anionic character of this carbon, in which the lone pair on nitrogen can be is donated to this carbon, and this bonding pair is then situated on the carbon like a carbon anion. So these indoles react with formaldehyde and amines to generate substituted indole derivatives, which are many times known as Mannich products. Indoles can further be reduced to indolenes in the presence of tin and hydrochloric acid. This will reduce the less aromatic ring. Benzene retains its aromatic character, and five-membered ring is converted into indolene saturated analog. Further, indoles can be condensed with aldehydes to give indolenines. Here, as I said earlier, this molecule can be thought of as existing in the two tautomeric forms, in which the lone pair on the nitrogen participates in forming that bonding pair and therefore gets a positive charge, whereas this carbon gets a negative charge. This can attack on the electrophilic carbon centers in carbonyl compound and form carbon-carbon bonds, and thus result into the formation of indolenine. So in the next lecture we will study about quinoline and its derivatives. Thank you.